Hey, Bogdan here. Quadratic functions made easy just for you. Another video series about quadratic functions in factored form. So let's dive in. Quick sort of recap. Factored form of quadratic functions, probably the most friendly looking, because from the way it is presented, it reveals very important things like, okay, leading coefficients, we already familiar with that, but you already have location of x-intercepts. So if you're familiar with solving quadratic equations already, if not, we have videos for you about that. We can quickly identify the zero values of the function, x-intercepts, point of intersection with the x-axis. Okay, so let's start with this beautiful example in factored form. So a is equal to -2, we can directly identify, and then x minus -3, so p is equal to -3, times x minus 1, so q is equal to 1. So by identifying quickly the values of p and q using that quadratic function formula in factored form, you average those x values. How do you do that and why this makes sense? Because of the symmetry. Every time you're working with quadratic functions, there's a symmetry about the vertex, right? So there is a line of symmetry that cuts through, and then when I have a horizontal line, I can always add those num points on the horizontal line together, divide by 2 to generate the location of the axis of symmetry. If axis of symmetry is established, I know the location of the x coordinates of the vertex. So hopefully this makes sense. So once we have -1 from this particular example, we get 8 by plugging in -1 back into the formula, and boom, we have the location of the vertex, -1 over and 8, and Desmos reveals that beautifully. So use that software. I'm not affiliated by any ways with Desmos, but I found it very nice tool for you. Every time when I see a function, quickly dive in, graph it. So it helps you to learn and understand a lot of things. So how do you find, for example, the y-intercept? If the graph is not presented, I don't have it, I don't know that necessarily this is 6. So put 0 back into this equation, because y-intercept is always found when x is equal to 0, and quickly solve for y. You can also convert this equation into the standard form by multiplying all those terms together, collecting like terms, and in the end you would get -2x squared minus 4x plus 6. So you can convert easily factored form into standard form and vice versa, because you know that this is factorable. So there you go. So the next example shows +1 for a, and then this is a specific case where both x-intercepts are the same. So even if you do the average, you identify the value of p and q, you add it together, divided by 2, you find the location of the vertex, and the y-coordinate for that vertex is 0. When it is 0, it tells you that there is only one point of contact with the x-axis, so parabola sits on x-axis. Whether it opens up or down, it doesn't matter, because there is a one point of contact. In this case, it does open up. So what else we can extract from this equation of the function? We know the direction of the opening. We identified the location of the vertex. We know that the vertex is the minimum value of the parabola. It's the lowest point on the graph. So that is very critical. In order to find y-intercept, not a problem, we put 0 for x, and boom, we have 1. You can expand it to get that standard equation if you choose to see it, so that you can confirm algebraically that the y-intercept is also 1. So hopefully this makes sense. The axis of symmetry is again correlated with the x-coordinates of the vertex. Bingo. So the next example, negative a in this time example, negative a represents the case where parabola must open down. So the vertex location would be considered the maximum point, the highest point on the graph. Now x minus 2 and x minus 6, those are the factors. So p is 2, q is 6. By averaging those two values, you get the location of the vertex. So 2 plus 6 divided by 2 gives me 4. How do you find 12? Again, you put back 4 for x back into the formula, do the calculations, and you get the location of that vertex. How do you find the y-intercept? Again, either you put 0 for x and quickly do the calculations, which is probably the most efficient way. If you choose to expand it and create a standard equation, also a method, maybe just a little bit longer, but it will give you the same result. So there you go. And knowing the vertex coordinates, we understand that this is the highest point on the graph. It's a maximum value. The graph reveals it beautifully, thanks to Desmos. And then equation of the axis of symmetry, you can write it as x is equal to 4, or you can use the standard equation of a line, x minus 4 is equal to 0. So hopefully this video now gave you sort of a better understanding of why and how the factored form of quadratic function works, and practice questions solidifies your learning. So share that video with your friends. Don't forget to do practice questions, because this is how you learn in the end. I'll see you next time with another video. Bye for now.